Hello everyone, this is a demonstration for Lab 27. In this demonstration, we're gonna learn about concept of a sub-assembly, and also I will show you how to make an explorer view of assembly so that you can see the whole internal part as well. Alright, as you can see, we need a part. Same way as you did it for the 25 and 26, I already made a zip file containing all the parts you needed. So make sure you make a folder and confirm that all parts you need in that folder. Then create assembly. But as you can imagine it, we had to make a multiple assembly. The first assembly you're gonna make is we're gonna name as a sub-assembly 1. In this case, I named it as a sub ASSM01. You can see it, same thing. We're gonna make one of them, and we're gonna repeat it. We're not making separate one by one again. We are making one sub-assembly, and we're gonna use this multiple times. And there's a sub-assembly 2. We are gonna make it this one of them. Then eventually we're gonna use all those together and making your final assembly. So one of sub-assembly 2, 1, 2, 3, 4 of sub-assembly 1. There will be a few additional parts to put them together. And as you can see also, we are going to make explorer view of one of sub-assembly 1 so that we can see all the internal part associated with that sub-assembly 1. Alright, let's just start. Alright, let's just start the new assembly. We're gonna use the same unit, millimeter, and the folder you start is going to be the folder you already have all part in it. So if you go there, my case, I named it as a Lab27 CH09 TUT03. So if you're using 7-zip and use that option we discussed in the class, I'm pretty sure same name should be there. So once you are in, okay. So now you can see it, the assembly, whatever I'm making, is going to be happen in that folder, which is the folder I already have a part. And of course, you have to turn in this whole folder for your assignment. I already seen a few students turning in only single assembly file. Definitely, I'm not gonna able to see how you did it. So make sure you are turning your assignment in the form of a folder. Inside a folder, all parts you used and the assembly you created, it's in it. Okay. Alright, let's start with the first sub-assembly. So let me name as a sub ASSM maybe 01. So that's the name, the first sub-assembly I am going to make, and I'm going to say OK. Alright, then assembly menu will pop up. Obviously, we're not doing this default part creation, so switch to assembly. So assembly, add component, all these things we went through. So now we started new assembly. It's time to load the part. Let's start with the articulated rod. It is in position, looks good. So I'm gonna say OK. Once I'm done, this is the starting point, so I am going to fix it before anything I do. So assembly constraint, fix the part I just loaded. So that everything else will be moving based on this part in this sub-assembly. Alright, so I got the first part in it. So I'm gonna add a component. The first thing I'm gonna do is the couple bushing there, so that if something part moving, it doesn't really hurt the part itself. The bushing can be replaced later on. So it's very basic of many mechanical part. So we're gonna put couple bushing there. So add a component. Load apart. Let me find the bushing we needed. So there's a rod bush lower side and there is a rod bushing upper side. So lower side go to that small side. The rod bush go to right there. So let me start with the lower one. All right. Then as you can see it, I can start make it as WCS. That's my recommendation, so that you can see what you've been loaded at, and also at the same time either move or constrain right away. So today I'm gonna use this add component window as move around your part. At the same time, I can also add the constraint right away, so that I don't have to add the assembly constraint later on one by one, which is fine, but this saves more time as well. So again, this rod lower side of bush goes there. So I'm gonna start adding constraint right away. Let me zoom in. So obviously I need to make a same axis aligned each other. So I'm going to use a touch align. Inter-center axis of this. Be careful not to pick up the surface. You actually pick up the axis, center line, then center line, right? Just like that. So they are lined up. Then I need to make sure the same level, right? So top of this to top of that probably. So I'm gonna change it to align, because these two faces will look at the same direction. So pick up there, pick up there, there we go, and that's it. It's already there. By adding those two constraints, as you can imagine it, there's no movement of left and right whatsoever, no pop out either, but as you can imagine it, this bushing should be still allowed to rotate with it, right? Because we didn't lock anything. So this two constraint is giving the only 1 degree of freedom. That is the concept you're gonna use a lot later on if you're doing more kinematics analysis. Also, as you can see, parts are same color, so it may be not really helpful. So I am going to change the color. So right click over the part, there's edit display, color ribbon, and let me start with this color. I'm gonna just go over these directions, right? And okay. Then push. Next color. There you go. It's much easier. So we got it. So let's put next one. Add a component. Open. And this time draw the bush. So right there. Right. Make sure you have a assembly location as WCS. It's much easier to see it. Then same thing. Move. If you want. Then I'm gonna constrain. Since I already have a line, so I'm gonna start with a line. Why not? Right? Just kind of have efficiency. Align those two surfaces. There we go. So they're same level now. Then I can have infer center axis, axis of this, axis of that. There we go. It's it. All right. So not bad, right? So open. I'm gonna right click, edit display, change the color. Next one. We are going well. So pretty good. So probably you find it yourself it's going way faster than the previous assignment you did it, because we are using add component. Then at the same time we are editing, right? We are editing a move or constraining at the same time within just add component. But everyone already know that. Later, if you need to add more constraint, you can just simply go to assembly constraint. You can add additional assembly constraint. Oh, one more thing. It's a navigator. Part navigator shouldn't show anything because we are working on the assembly. So if you want to see the progress you made it so far, always you can go to assembly navigator. Then it will show you the part so far you loaded, and it will show you also, let me make this window bigger. It will also show you which part been edited with what kind of a geometrical constraint so far. Okay, so this is a tracking of what you've been doing so far. All right, so add more. So next one, I'm gonna add a piston. Piston is right here. All right, so orientation is not quite as I wanted. As you can imagine, I am going to put this goes in right here. So I'm gonna move first slightly. Doesn't have to be perfect. Just it's easy for me to see what's going on. And something like that. That's good enough, I think. Somewhere, right? Closing up. All right. Then I am going to start adding constraint. Now, do you remember just like we did it in the pipe vise? I need to find out what kind of distance I have between these two. So I almost forced not to add the constraint yet. So I'm gonna just say okay for now. Just move around, right? So I'm gonna go to analysis, measure the distance from there to there. So that is 50 millimeter. Cancel. Another measure. There to there. That's 42 millimeters. So there's 8 millimeters of differences. So to make this piston exactly at the center, I need those gap 8 millimeter is distributed two places. That makes that I need to make the distance from this to this only 4 millimeter. All right, so I got the idea. So I am going to go back to the assembly. Finally, added the geometrical constraint. In this time, distance, this to this will be 4 millimeters. So 4, enter. Then you can see it. They labeled exactly a 4 millimeter gap, right? Because I already used the half of the differences, the other side should be automatically perfectly 4 millimeter as well too. So good to go. Then I can start moving, align this one to there, right? So I'm going to have assembly constraint, touch align, infer center axis, axis to axis. There we go. Perfect. So now they should be pretty good shape. So when you move around your piston, if it was not perfectly aligned, well, you can come up with some additional constraint, such as you can make that perpendicular, right? In that case, this surface and this surface, you can make it as a perpendicular. That will maintain perfect orientation. But as you saw it in the process of moving the component, this piston, I tried to make 90 degree already, what I wanted. All right, so option for now. All right, I am putting the pin there so that piston doesn't pop out. Add a component, open, and there's piston pin there. Okay. All right, it's already located. So I'm going to move first, get closer. There we go. Then constraint. So in this time when I do that, I want to make sure center of this is perfectly center of everything. Okay. So we already learned how to do it, which is utilizing the datum belong to the part. To do so, I need to activate those datum belong to the part. So it is forcing me again get away. So I'm gonna have just say okay, locate it, and right click over the part, replace reference set into entire part. By doing so, just like that, you are going to be able to see the datum belong to. Same way I'm going to do to this part, entire part, then you can see it. Datum is there. So I'm going to make the same level. There's two datum, XY belong to this part, XY belong to this part, need to be same level. So I'm going to have an assembly constraint, align, X and Y, X and Y. There we go. So they are perfectly lined up. Then, of course, I'm going to send this pin exactly at the center. So touch infra center axis, and sometimes it's hard. Be careful not to pick up the constraint you added it. Dot, 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 right? You know, that's the center line. There, confirm. Well, if it's way too close, then obviously the NX is smart enough to asking you to confirm. So that's it, confirm. Then you can see it, the piston is already in. It's hard to see because of same color, so let me change color again. Pistons, this color probably, and piston pin, this color. There we go. So it's too close. Let me change color again. Maybe more greenish. There we go. Hopefully it works. All right. Not much, but you got it. So now I got the piston pin exactly at the center, symmetrically. So now I need take off the datum, because it's, imagine that there are like 100 of this part where the datum shows up in the assembly. It's gonna be really confusing. So I'm going to replace the reference set back to model, so that only the solid model is showing up. Same way for the pin. There we go. All right, so first again, we're almost there. So we are going to put the plug at the top and bottom. Move component, I'm sorry, add component, open, plug, open. So it is there. I'm gonna move first a little bit so that I can see much closer. So try to be making this one goes in. So obviously I need to make an axis aligned it. The bottom of this plug head should be touching the top of this pin. All right, so constraint, infra center axis, axis to axis, they're aligned. Now I'm going to make touch, because the bottom of a head should aligned with this one by looking at the different directions, right? Opposite directions. So that's the touch. So this and this. There we go. It's in. So in position. Okay. Change the color again. Alright, so I got the plug in one side. I need to do exactly same thing for the other side. So I'm gonna add a component again. Open. And I can choose again. Or since this part is already been loaded, actually I can say loaded part. Will show you so far the part you loaded it. So you can choose from there as well too. So let's try, why not? Alright, so that is the one. Move. It's showing you where it is, right? So I am lowering down so that I can send it nearby. And we know the direction, it has to be rotated. So I know as we adding the geometrical constraint, it will do it by itself. But I want to see it, what's going on. Oop. Well, I accidentally already put it there. Alright, why not? I can do it. So I am going to make a line at the same level first. So assembly constraint. Infra center, let me do touch first. The bottom of the head and the top of the pin. So you can see it right away, flip it, it aligned it for me. That's good. Then I'm going to add infra center axis, axis, axis. There we go, it's in. All right, so if something happens just like this, you don't need to panic. You always have a chance to go back and fix it. All right, change the color. Same color with the top one, probably better. There we go. So now if you press the home button in your keyboard, you should give a trimetric view. We're almost there. So we got the articular rod, bushings in, pistons in, pin, plug. So now we need to put the ring, right? As you may already know, the internal combustion engines has to separate the combustion area with actual engine oil blocking it. The gas is not leaking, those kind of stuff. So we're gonna put those rings there. All right, so let me put the ring right here. Okay, then I'm gonna put more like this, right? So adding the component. I don't have a loaded part, right? So I'm gonna open new one. That's the piston ring. Okay, that's right there. So I am going to add a constraint right away. So the first thing I'm going to do is top of this ring touch this groove head there, right, upper part of groove, so that they touch. Then obviously axis and axis need to be constrained. So okay, let's try top and this upper part of this group, touch, confirm. There we go. So they are imperfectly aligned right there. Then now I need to make sure this axis is aligned with the piston axis, right? So I'm gonna have info center axis. It's very tiny, be careful. Pick up there, and axis of a piston. Pick up there, confirm. It's in. Say okay. You can see piston ring is in. So change the color. More dramatic color, probably better. How about this one? All right, so ring is in. Well, let's say the process of you putting ring was not really helpful or enjoyable, a lot of effort. So if in that case, you wanna get it done automatically. So as we did in the part design, the pattern feature, in assembly we can do pattern component, the pattern the part. So we're gonna repeat it. So that is right here, the pattern component. In some reason, if you don't see all those, the menu you're seeing here, make sure you change the role. Okay, change the role as advanced one so that you can see all those, the menu you needed. All right, so I'm going to do the pattern, but I need to know the gap, right? I need to know how much from one to the other group. So I'm gonna again measure from there to there. Well, according to this measurement, there is 5 millimeters of gap there. So if I repeat this with a 5 millimeter, automatically it will be there with this direction, which is linear in this case, right? One directional repeat. All right, got the idea. So I'm gonna have pattern component. Then it's asking to which component will be pattern. So this piston ring. Then it's going to be linear. So specify the vector, so the direction. So I'm gonna just pick up the cylinder here. Then the axis of the cylinder will be the direction of the pattern. Click, then you can see it now. You already got the idea. So you kind of showing the preview of one, and just like we did in the part, then there are 3 methods: count and pitch, count and span, pitch and span. Count and pitch means how many, including the original one, and what's the distance each. We can actually using this one. So in this case, including original part, we have 4 of them. The distance between should be 5 millimeter. So that's the information we have. We can use that one. We can have a count and span also too. If you know how far from beginning to the end, if you know how many has to be thrown in, then you can use this method. Or same way, pitch and span. What's the distance each of them, how much space you have, then automatically how many can be added into, then distance of each will be automatically calculated. But in this case, I know how many should be and what's the distance each other should be. So I'm gonna have manually 4 of them with 5 millimeters of gap. There we go. And say okay, then right away you got the ring. Well, actually I have one more ring to go. In piston you not have only oil ring, they call it gas ring also there. They're slightly different ring, but to simplify this process we are using same ring. So I'm adding one more ring right there. Open ring. Where are you? There we go. So I'm gonna have about touch first. It's kind of difficult sometimes. Touch. There we go. It's not behave properly actually. Oh, there we go. Select to object. There we go. And there we go. Alright, they are aligned. You can see it. They're touching each other. So now I need to make axis aligned. So info center axis. Give me the axis. There we go. And give me the axis. Right. Not that one. That one. There you go. Confirm. It's in. Okay, and let me change the color also. All right, so as you do so, probably you notice that in the part assembly navigator, you're seeing the parts being loaded and the constraints of file loading will be accumulated. But instead of making it a one by one showing up, if it's a repeated part, it is actually say how many parts have been edited and so on and so on. So if you actually click one of them, it shows all parts you've been working on. But you will see later though, the one of a pin, maybe one of a ring in this case, is maybe need to be pushed away, or maybe you want to do different things with the rest of them. So obviously this grouped one is not going to be really help to individually access or doing something. So in that case, you can actually unpack it. So there is an option. So you can right click, you can unpack it, then you can see all ring you've been using so far, so that you can have separately do something about it. You can have additional constraint maybe you can when you do explore view, you can move only one of them, those kind of stuff. But so in this case, I will just keep it as all of them as a pack together. So to pack back, you have to click the first one and press the shift key down and click the last one, then it will select all of them. Or you can use control button and select all of them one by one. But in this case, obviously I'm using shift key and click last one, then all the file will be selected, then right click, you can pack it back. Okay. Alright, hopefully it is helpful. Alright, we are done. Actually, this is a sub-assembly 1. So same way, I am going to have sub-assembly 2. Pretty much the same. There's only a couple part differences. So let me fast forward. So you will see a little bit speeded up, but you got the idea. Same procedures, same part. Mostly only a couple part will be different. All right, let's start new assembly. Oh, sorry. So I am going to go to File, New Assembly. Okay, don't add assembly over assembly. File, New Assembly. In this time, I'm going to, so you remember where we started. I'm gonna start make it as a sub ASSM02. Okay. All right. So it's asking to load. So the first part will be this one, the master rod instead of reticular rod. Okay, it is there. So I'm gonna have fixed constraint done. Then I'm gonna have a bushing. I'm gonna have a bearing, which is a much bigger one. You will see it. Then rest of the process is pretty much same as what we already saw it. So again, I'm gonna do a little bit fast forward. You can slow down the video if you wanna watch it, but you already got the idea. All right, let's start. Well, I made a mistake here. Let me try again. All right, so assembly 2 is done. So now we have assembly 1 with articular rod, assembly 2 with the main rod there. So let's make our final assembly. So I'm gonna start a new assembly. I'm gonna name that as final ASSM. Okay. Alright, so now we are going to use those sub-assembly we already made it. So I'm going to go to find our sub-assembly. So I haven't saved it yet. So it's a previous one I already made it. So let me cancel it. And I am going to finally save it. Or go File, Save. Or you can just press Save button. So it's saved. And this is saved also too. So now if you go back to the folder, let me open it right there, right? Sub ASM02, sub ASM01. That's the new one we created. So this is final. We're gonna make it. Alright, so if I go back to the final assembly, so now it's gonna add the component, right? So the first one you're gonna add is that sub-assembly 2. So one of them will be used. So it's not moving, it's kind of stationary. The rest of them will be moving around. So okay, it will be there. All the color you had there just for the display in the sub-assembly is not going to be showing up. So don't get disappointed. And this time I'm going to of course fix the whole thing. There we go. So now it's fixed. I'm going to add more part, which will be the articular rod. So I'm gonna have add component, open, sub-assembly. There we go. So it's there. So now I'm going to put this one. You can see in master assembly there are 4 holes. We're gonna try to slide in there 4 of them together. To do that, obviously we need to work on first, let's align first. So this axis to this axis. There we go. They are perfectly lined it up, but level is not there, right? So we're gonna have touch. Oh, not that one. Touch this into this. There we go. They are in position. Don't worry about overlapping of part yet. We're gonna fix this later on. So let's repeat for the other 3. So I'm gonna have add a component, sub-assembly 1, then repeat it, right? So there. So let's do that for it. Alright, so I added full sub-assembly 1 into this. So if you right click and move, then you can actually move this sub-assembly. But see what happened? It's gonna trying to add moving the part. So fix the part. So it's kind of suspicious now, right? What do you mean I fixed it? So what we fixed was this one. So if I say yes, see what happened? Like this. Can you see that the form, the assembly is actually breaking out? So to avoid this is what you have to do. When you move sub-assembly within the bigger assembly, and if you try to move, do not use right click and move. It's good for one assembly, but if you have a sub-assembly to move, use move component. It's a different. So right click and move is moving the part you selected. But if you're using move component, if you select the assembly, the whole sub-assembly is recognized as a component. So then if you turn on the dial, you can see it, the whole thing will be able to move. Okay, so there's the differences. Okay, make sure you know the differences. So let me move a little bit. It's not perfect yet, so that it helps. So move component, this sub-assembly, turn on the dial. There we go, it's going up. And move component. There we go. Move component. There we go. So we kind of separated them for now. Alright, obviously to make this sub-assembly not to fly away, we need a pin to hold up. So we're gonna add more component. Open. What we're looking for is a link pin. It's there. Let me move a little bit. So I'm gonna insert this pin into it, obviously. So constraint, I'm gonna align first. That will be easier, just to avoid later overlapping. Well, it already happened, so I'm gonna move. There we go. So they're aligned. Now I need to decide how far I need to go in, right? So I'm gonna have touch top of it with bottom of the pin head right there. There we go. Then you can see it's inserted. Looking good. Well, so still you can just change the color one by one if you like. Let me give a little darker color. So pin is right there. And if you know the angle, you can actually do the pattern of this component also too, based on this axis. I don't think it's exactly the angle samely distributed, so I will just do one by one. Alright, we got it. Oh, I realized that I didn't turn off the... Oh, how did it happen? I don't know. Still the datum is there. In some reason, datum is turned on. So let me change it, sorry, to the model. Alright, much better, clear. So now I need to make the angle between. If you look at the book, actually it will show you exactly what the angle must be. If you look at the page number 9-34, I believe. Oh, I'm sorry, it's in 36. 9-36. It shows the angle you need to supposed to put it in. So it's a 75, 75, 70, 70, 70. So right here, between the master with the articular, is 75, 75, 70, 70, 70. Okay, so between these two, 75, between these two, 75, between these two, 70, between these two, 70, between these two, 70. All right, so we're gonna add the brand new constraint, assembly constraint. So to make that angle coming out exactly, I'm going to turn on the reference. So since I'm doing one, the other should automatically do it. Same thing I'm gonna do to the master rod as well too. There we go. So now we have a plane we can use for angle. So GX plane of each articular rod, and you can see also GX plane of master rod. I can use those for measurement of angle. So if you go to assembly constraint, the new one is right there, angle. There's already an angle, 3D angle, but in this time 3D angle works perfect. So I'm gonna measure between XG plane belong to the master rod, confirm, with XG plane belong to the first articular rod, there, confirm. The angle shows up. There is also, obviously, since we have a 360 degree of form, you can actually play with the angle right here to find the angle you are looking for. So 180 degree minus 75, that makes that 105. That will give you 75 degree, right? So find the angle you are looking for. I think the way of I measure is not right. All right, so I'm gonna just put manually 100, 115. That should give 70 in the other side, right? There we go, done. All right, same way, you can just measure between the rod also too. Angle between, I think it's a matter of sequence also too. Let me choose this one and this one, see what happened. Yeah, same thing. Okay, so I am going to have 115 and will give actually 75. There we go. Okay, and I want another between this to this, and this time I'm looking for, we got it in this time. Probably not. Give it to me. So actually we are looking for 110, right? That's how we're gonna able to get 70 degrees, right? So 110. There we go, got it. And finally I have one more. This, this. Oh, we got it in this time, right? So, clockwise. So, clockwise sequence is giving the right one. Okay, so I could have this to this, this to this. Okay, got it. So 70. Oops, 70. Enter. No, actually, it didn't go that way. 110. There we go. Is it right? I feel like I'm missing something. Well, you got the idea. Let's say it is right. I'm supposed to have a 70 left. 115, 115. They mix that. 75, 75, 70, 70. It should be 70 left, but looks like it's way more than that. That is weird. Okay. Okay, I fixed it. I did a wrong calculation. So to get to 75, 105 need to be there, 105 need to be there, 70 is 110, 110, 110. Okay, my math problem. Okay. All right, so we got the O angle we needed. So now I can hide those datums. So that we can clean solid models there. Some people also asked me, oh, is there a way I can not seeing this constraint? Yes, there is constraint groups, so again, showing so far what you've been doing it. You can actually right click and right there, display constraint in graphic window. Right now it's checked mark. If you uncheck it, it's not gonna show up there. So it's gonna have a much clean one. So for now, I wanna see it, because as we learned, if there's a constraint conflict each other, you can find out very easily because the color will change automatically. And also, same way as you're seeing in the subassembly, subassembly 2 being used only once, subassembly 1 used for 4 times, it's been suppressed like that, right? All right, so now, also in the assembly, if there's a subassembly, the subassembly constraint and the component being used also will be displayed in your assembly navigator as well too. So it's kind of showing you the big pictures and the way the parts are being put together, which part we added it, and so on and so on. All right, so now we're almost there. Let me save it before I lose it. So I'm going to make explode view. That one is showing the internal view or internal parts which is covered by each other. So to do so, right there, again, under the assembly group, there's explosions. I'm gonna turn on the explosions. Then this is a new interface with what you're seeing in the previous video. Right now, we don't have any exploder view being created yet, so I'm gonna create a brand new explosions. Right. Then it will ask you, edit component window will pop out. Then you can start moving the part you wanna move. So in this case, I wanna move this whole things, including this sub-assembly itself, will need to be moved out, right? But when I move out, I want to make sure it follows the direction of angle I already have it. So I'm going to choose only one of this. But when I do that, as you can see, when I try to click one by one, it chooses only the one component. But I want to have this sub-assembly move. So you got the idea, right? So I am going to actually unpack it. You can see it's sub-assembly been separated now, right? So sub-assembly 1, 2, 3, 4. This one, this whole sub-assembly I need to move. So I am going to go back, double click. Then if I choose the component, okay, let me create a new one. I don't know why it is not working. Oh, I need to edit. I'm sorry. So I created one. Now I need to edit. Sorry, I don't know why. Okay, edit. So instead of choosing part one by one, I'm going to be able to choose whole subassembly just like that. So that's how ungrouping can help. So now I'm going to move. So I'm going to specify orientation. Then good chances are they are lined up or maybe not. So there's some cases maybe your dial is not lined up with the angle you want to move. Let's say it was something like that. Then probably you already saw it. You can actually move handles only as well too. Okay, so that's why you can do it. But now, actually, I am not going to do that way. So hold this sub-assembly. I'm going to move handle first so that I can have a alignment perfectly direction I want. Then again, this one, I'm going to pull out whole things, not handle, whole things. There we go. You see the whole assembly being popped out. And say OK. So as soon as you say OK, what it does is it remembers this last position. Okay. Then I can continually edit it. I can edit. Now I can do within the part. So I am going to pull out. Let's start this piston. So instead of one by one, if it's allowed it, you can actually have a window, and whatever the component within the window will be selected. So like a click and like this. Then everything which was in the window will be selected. Now oriented. Oh, too bad. The handle is not aligned as I wanted it. So I am going to move handle only first. There we go. And now I have to do it again. Select within the window. Now only handle. I don't know why it is keep doing this. There we go. Let's try again. Edit. Component. Orientation. This is not fun. There you go. Much better. So keep selected was the options. Okay. Then turn up the move handle only. There I'll be able to pull out. There you go. Looks better. Okay. Now I have more part to be pulled out. So I'm gonna edit again. So in this time I'm gonna select one by one. Ring, 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 and another ring. There we go. And move. Oh, this is not good. So I'm gonna keep the selected. Move handle only first. There you go. That's the direction I'm gonna pull out. Turn up the move handle only. Then pin's gonna pop out. Rings gonna pop out. So, okay. So again, remember, whenever say I OK, this position will be remembered. So if I turn off, double click, it will go back, right? Explosions off. If you turn on, double click, it will turn on, right? So I'm keep editing those final explosion scene. Okay, so edit. I'm going to pick up more. So this and this. Maybe I want to pull out pin. Yes, that one. I think that's it, right? I want to take that out. Oh, also pushing too. There we go. Then orientation, I should be able to pull up. There we go, all of them are coming out. There we go. And say okay. Edit one more time. Component this and this. Orientation, pull up. There we go. Looks good. Okay. Edit. Well, again, some cases you don't like the way being all of them move together, then you can individually move, obviously. There we go. And actually we have one more component. This one need to be down. There we go. Looking good. All component has been out. Oh, you know what? I'm gonna pull out this pin also too. That looks good. Say okay. That's it. So this is the final scene of my Explorer view. You can see edit, and whenever I say okay, it will be remembered. All right. Sometimes you need to select the keep the orient selected, so that if you want to do multiple steps within the same component that you selected. All right, looking good. So now, additional thing you can do it over here is actually giving people the instruction how those parts goes together by the trace line. So that is the creating trace line. And all you gotta do is find the center piece or the vertex. So in this case, I wanna use the center of this to center of. I need to find the right angle right there, and say okay. Then you can see it will make a trace line showing the how this part should go on. So if you turn off, it's gone because it is available only when it's exploded. I'm keep adding another trace line between this to this. Okay, showing good. Maybe I can do another trace line all the way through there, all the way to down. It's gonna be good presentation. There we go. Same thing, trace line. Maybe this one all the way down to there. It will give the good sense of how it's assembled. Then finally, when I add the trace line between there, sometimes it's not really working as expected. As you can see, it is kind of awkward, right? It could have been just straight. So actually, you can move around this small manipulation, or there's a alternative solution. You will try to find the different ways. So now you can see it. This one works way better. So instead of trying to manually move all around by yourself, sometimes this alternative solution works really great. There we go. You got the good sense. Same thing between these two. Oh, I don't like it. Alternative solutions. There we go. You found a good one. I will lower a little bit. That's fine. And okay. And okay. There we go. So I got the trace line on as well. So now it's on, off. Let's change the angle. Double click on, double click off. So double click on. That way you will show everyone how this assembly being made. Well, it's been like a long time. According to my clock, it took over 1 hour. So, well, because I was explaining it, maybe it took a long time. If you do by yourself, I'm pretty sure it's not going to be really that long. So sequence is making the subassembly 1, subassembly 2, then making final assembly, connect them with a pin, Then you're gonna make Explorer view. When you make Explorer view, you have editing, right? You can select the component, do it. Oh, one more thing. Since I already done with selecting this component, I can just push this back, right? Group it. Okay, so I'm gonna select all of them, say group it. I can group back. Oh, where's group? Oh, pack. I'm sorry, not group, pack. Right, so I can put pack back. The reason, again, do you remember why I ungrouped it, unpacked it? Right? Because I want to select all components belong to the only one subassembly, right? All right, hopefully it was helpful. Obviously, if you want, you can just change the color again. You can play around. But again, that's what I'm looking for. So when you turn this in, if you save it, in the folder, there should be all part, of course, and two subassembly you made, and the final assembly you made with the Explorer view is turned on with the trace line. All right, have fun. It will give you the really good exercise of making part and subassembly and put as a part of a component for the bigger assembly. So I'm pretty sure it will give you also a good sense how you're gonna work on for your final project as well too. All right, keep up the good work. I will see you in class.